Hey there, Internet. I was thinking to myself, how could I get more wires involved in this project? I've got like my spindle wire here, I've got all these ground wires, I've got ground earth wires, I've got shielded cables, I've got an ESP32, I've got gobs of signal stuff for the driver controllers. I got all kinds of wires. I thought, man, if I could only have more wires. so, so I decided to wire this thing up, and what it is a servo, and its job is to turn a knob. Now, I can turn a knob, but the problem is that when my machine does something it shouldn't be doing, for some reason my first reaction isn't always the right one. The first reaction really should be to hit the reset button, or the e-stop button, or whatever you've wired together. That should be your first reaction. But in this setup, this isn't connected to anything else, so when everything else stops, the spindle is going to be still running. So what I've done, which is I think antithetical to my goal, is what I've done here. Oh, look at that! There it is. Oh, did I get it on camera? That is awesome. So the heating system in the apartment just kicked on, and there's so much EMF in this apartment that that my brain box over here thought it was a signal to turn the spindle on, and it did turn the spindle on, but I didn't actually want that to happen. Anyway, so this actually works sort of. Right now, I've got it hooked up to a ESP32 with nothing else, just to make sure that I you want to reduce the number of variables when you're messing around with this kind of stuff. So I've got my STM32, I've got my spare I'm sorry, this is an ESP32. This is a blue pill STM32. This is my spare because I'm so smart that I set everything up on a different computer, and I have to disconnect all the wires, walk it into the other room, program it, and bring it back, and then reconnect all the wires just to test to see if something works. So anyway, this is my transport, my 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 intra apartment internet service, kind of like the clay pigeon. Never mind, I'm not going to talk about Larry Wall right now. So anyway, so I've got the STM32 hooked up. It's listening to this little wire right here, which is sending the spindle PWM out signal, and it's using a timer to measure the width of the PWM pulses, and that gives me a duty cycle between 0 and 100, which is good enough for what I want to do. And then it's also hooked up to this little OLED screen here, which of course it never sits the way you want it. You see that? That's engineered, and it's designed that way for maximum. There it goes, maximum frustration. Never where you want it. Maybe if you just, I think you just have to break the wires to get it to sit the way that you want it to. Anyway, so this this gives me the display of a number of things, and one of the things I was thinking, in addition to just turning the knob, is maybe I can pan. Oh, nice smooth pan. Oh yeah, that works pretty good. I've got a retro reflective sticker here. Where is it? Here it is. And I've already tested this. It works pretty well. I've got a infrared proximity sensor, and I can just mount that right here behind the spindle. And assuming that everything goes well, which is absolutely the wrong assumption, because nothing will go well. But assuming everything goes well, I can actually do a PID control, where the knob, instead of just guessing what the spindle speed should be, it'll get feedback on the actual spindle speed, and then it'll be able to do the knob twiddling that it needs to do. Now, I just made a big mistake. I actually touched the spindle while this thing was hooked up, and as you saw before, it could turn on at any moment. So that's super dangerous. So I shouldn't do that. But I was smart enough to take out the cutter. So anyway, so here I go. I'm connected to the ESP32. I've got my sender interface up and running. So if I do M3S1000, And then if I hit M5, it shuts off. Now, one of the really interesting bits here is over here. Let's just look over here where I got, I have no, I have, the other important part of this project is I had too much room to work. So I had to make sure that I limited the amount of room to work so that my stuff is literally almost on top of itself everywhere that I turn. Here is the signal. It's not actually connected to the servo signal, and it's surprising that that works. It's also surprising that the PWM input works, and I'll show you why. I'll go ahead and run the start command. So that's not great. I've got it set to about 800 millivolt, and so you can see it's tripping out on the over 800 millivolt when it should be low ish. Anything over 800 millivolt will be anything on 800 millivolt would be interpreted as a digital high. So, well, I guess a good demonstration is here. I'll see how my camera work is here. We'll get zoomed in on the screen. Focus. Digital zoom. Can I do it? Can I pan the zoom? I don't think I can. All right, there's my digital zoom. All right, so I'm going to turn the spindle power off. Now, what this should look like, I'm going to hit M3 S500. You heard the knob turn, and you can see 49. That's my duty cycle. So it should be 50, but it's close enough. Now, if I do M3 S100, now you can see it's should be 10. It's actually 9, close enough, right? Now, watch what happens when I turn the motor power on. I gotta actually click. This should click off. All right, we want that to click off. I'll turn the power on. It's got a safety feature where that's got to be off before you can turn the power on. And then I'll go ahead and I'll start it up and note the values here. The first value is the whoops, got my finger in the way. The first value is the duty cycle. The second value is the angular position of the servo. The third value here is the last pulse. And I have that in there because I was debugging some stuff. I can probably take it out. I've also got a M0. This is a Boolean, 0 or 1, so that means I've got a little timeout for the motor movement. And I'm not sure what DC is. And then I've got an RPM signal, and that's eventually going to be used for detecting the RPMs of the spindle. Now, interestingly, nothing's happening, and it's at 240. I have no idea what that is. I think the pin just floats, and it's ambient noise. So here's what I'm going to do. I'm going to go ahead and turn on the power, and I want you to pay a particular note to these things here, because these are supposed to tell the servo motor where to go. And when M is 1, that means that we've recently issued a move command to the servo. M3 S700. It's behaving now. Before, these were like 2,000, jumping all over the place. There you go. See that? That should never be bigger than 100. And that number should never be bigger than 300. So that's bad. I don't even know how this is actually working. You can see there's move commands happening, but nothing's actually happening. And when I hit M5, it correctly shuts down. That doesn't make any sense to me whatsoever. I mean, the servo should be jittering and jumping all over the place. Now I've set the servo up so that it shouldn't move unless the signal's more than 20 degrees. Maybe that's what's saving it, but I think this thing is super dangerous, and so far it's a terrible idea. But it's been fun. It's been kind of fun. Um, I wish I had I wish I had something a little bit better than this for my spindle control. And again, the machine starts to crash here, and that puppy starts to do bad things. You want the spindle to stop, and right now I don't have a way to do that. I guess I could. Maybe the safer thing to do would be to wire up a contactor to kill the power, but that's bad for the spindle. So I don't know, but it's something. Anyway, thanks for watching.